To see Canada from the air is to be gripped by the magnitude of opportunity. Here is an area larger than 90% of the Earth's other nations. A land brimming with resources, natural treasures that could never be brought to their full potential were it not for one vital link. That link is lubricant, the lifeblood of the heavy equipment that enables Canadians to make the most of our natural resources year-round. Making the right choice in lubricant would be critical in any country at any time of year. But in Canada, choosing the right cold-weather lubricant is imperative. That single decision could ultimately mean the difference between profit and loss, between prosperity or failure, between a vibrant, thriving place to work and nothing. Look closely now. You're about to meet one of your Cold War enemies. These are wax crystals. Wax is a key component in the base oil that goes into the vast majority of today's lubricants. This computer animation represents a single molecule of wax. As the temperature drops, wax molecules nest together, a little like stacking lawn chairs. In this formation, oil molecules get trapped between the wax, and everything sets up into a semi-solid mass that can render even the most powerful equipment helpless and immobile. Dealing with wax is just one of the challenges lubricant makers must address when they blend their products for winter performance. It's just one of the reasons some lubes have better fluidity than others. In this research cold room, 5 grades of heavy-duty engine oil have been chilled overnight, all the way down to 35 below zero. As this demonstration suggests, at minus 35, the fluidity of these 5 oils is very different indeed. Now, what do these differences mean to you and your equipment? Well, there are really 3 key points to remember about winter lubrication and what it can mean to your performance. Start up quickly. Warm up safely. Stand up to operating temperatures. The first of these key points is that the right lube will have the fluidity to help you to start up quickly. That fluidity will also allow your equipment to warm up safely. Yet for all that fluidity, once the equipment's up and running, the right lube will now undergo an almost magical transformation. It will now have enough body to stand up to the demands of full operating temperature. Let's see what's involved in a typical cold weather startup. Here are 2 heavy-duty engine oils. The temperature in our cold room is once again 35 below. The oil on the left is a synthetic blend 0W30. This is a 15W40. Normally a fine choice of multigrade, but at minus 35 Celsius, the oil is just too thick to enable the engine to turn over and fire. Anyone who has ever heard that sound, and is there a Canadian who hasn't heard it at one time or another, knows the importance of being able to start up in the cold. When outdoor equipment fails to start, it can do a lot of damage to a production schedule. And it's not too much fun for your equipment. To give you an idea of what we mean, we brought some passenger cars into Imperial Oil's cold weather test facility, where we'll be able to see just what's involved in a startup at minus 35 Celsius. To get a better look, we took off a few parts of the engine. Keep in mind, that although this is a passenger vehicle with a gasoline engine, the principle holds true for any kind of equipment you may be running in the cold.
Exhaust is on, and crank.
Key on.
The oil in this engine is a 0W30 synthetic blend, and it does exactly what you'd like an engine oil to do in a grader, bulldozer, or tree harvester at 35 below. It starts up quickly. The engine started quickly, but just as important, the oil began to flow almost instantaneously. Exactly what you want in a safe winter warm-up. Still, if we take another look, we'll see that the oil appears first at cam tower number 1, then at number 2, number 3, and finally number 4. When you're getting a good flow of oil, that small difference in lubrication time is negligible. But now, let's see what happens in a more typical situation. This time, the oil is at 10W30, the grade still used by most Canadian drivers. Once again, although we're looking at a passenger car, the principles hold true for your heavy equipment come winter. In a test facility like this, with lots of spare parts nearby, we're able to keep on cranking away just to make a point. In real life, of course, you'd never crank for more than 30 seconds straight, since despite the extreme cold, that action could melt the solder in your starter and burn it out. 35 seconds after we start cranking, the first oil appears at the cam tower. Does that cloudy quality look a little familiar? You're right, that's wax in action, or more accurately, keeping any action from taking place. With 10W30, it took 1 minute and 10 seconds of cranking or chopping up that heavy oil before the engine could get up enough RPM to start. That's over 1 minute of metal-to-metal contact. Now, at this point, many operators would breathe a sigh of relief and get on with the job. The engine's up and running, so we're ready for the cold, right? Well, let's take another look at those 3 key points. Start up quickly. Warm up safely. Stand up to operating temperatures. After the startup, the right lubricant will enable your equipment to warm up safely. How important is this? Let's take a look. We're going to see another demonstration at -35 Celsius to show what can happen in the warm-up stage when you've made a wrong choice in engine oil. This is a sump or oil pan from a heavy-duty truck, the place where engine oil lives through those long winter nights. If the right oil is used, it will quickly pump up from the oil pan and into your engine where it belongs. But now, let's see what happens with the wrong engine oil. Until the engine warms up and the oil reaches a temperature at which it can properly flow, there'll be parts of the engine that are literally starved for oil. Other parts will receive a mixture of oil and air bubbles, and, as we all know, air in any form is not a lubricant. Let's see it again, and keep in mind that what you're viewing could all take place without the driver having any idea about it. And that brings us to key point number 3. Our first 2 points emphasize the need for lubricant fluidity. Fluidity for startups and fluidity for warm-ups. Now, for key point number 3, that same oil must make an almost miraculous transformation, one that will now allow it to stand up to the rugged demands of operating temperatures. Because, no matter how cold it may be outside, there are parts of your engine where the temperature gets up to 350 degrees Celsius or 660 degrees Fahrenheit. All told, the wrong choice of engine oil alone accounts for part of the $5 billion that Canadian industry will pour out this year. Money wasted by making the wrong choice of lubricant. But the story goes far beyond engine oils. Most operators are already aware that the wrong engine oil or transmission oil can do serious harm to their equipment. But when it comes to gear oil, grease, or hydraulic fluid, those 3 key fundamentals of winter lubrication still apply. Take gear oil, for example. When you make the right selection, you're able to shift smoothly through the gears shortly after startup, and you get even distribution to the bearings and gear teeth. But, as we'll see, with our cold room now taken down to 40 below 0 Celsius, all gear oils are definitely not the same. This is a channel test. It simulates the motion of a gear tooth cutting through the fluid in your gearbox. These products are all multi-grade oils, but at 40 below, some of them aren't too eager to slump back into place, where they can give your gear a full measure of protection. Notice how the two 75W90 oils slump back almost immediately, ready to go right back to work. But other oils, especially the 85W140 on the right, may retain the channel. The next tooth to come through here will just be passing through air. Why is fluidity so important to your choice of gear oil? Well, in many heavy-duty applications, the entire weight of the load comes to bear on a single gear tooth in your final drive. This is why high-quality gear oils are blended with the optimum amount of EP, or extreme pressure additive. With the help of computer graphics, we can get a better idea of why a continuous flow of EP is so important. Normally, the EP additives, represented here by the red line, bear the brunt of the load. But when cold weather channeling keeps the oil from getting to the gear teeth, that same protection is no longer there. Consequently, the bare metal surfaces meet up, then heat up. They literally weld together. This newly bonded metal then tears away, leaving the surface of the tooth more ragged than before, and a major breakdown just around the corner. Take another look. When low temperature channeling takes place, the gear oils lack the fluidity to slump back into place. They're no longer in any position to provide that steady flow of lubrication. Cold weather makes special demands on hydraulic fluids too. We're looking at a lot of action here. But in most operations, you also have a lot of machines that are just waiting around for other equipment to make something happen. When they sit idle in the cold, hydraulic oil, especially in smaller lines, can chill and grow sluggish. It's more difficult to maintain a smooth flow of activity. Precision moves become that much harder to nail down. Will the right selection of hydraulic fluids make a difference to your winter operation? Can you overcome problems with the right choice of oil? Well, let's see how two supposedly identical grades of hydraulic fluid perform in our cold room at -35. Even in a race course that can be measured in inches, the difference in performance is clearly visible. But if you multiply that difference in fluidity by every activity in every piece of equipment, you'll see why hydraulic fluids for winter must also be chosen with care. Perhaps the most misunderstood lubricant of all when it comes to cold weather performance is grease. With recent advances in automatic greasing systems, it's easy to understand the attraction of a set-it-and-forget-it approach to greasing equipment. And if the weather were anywhere near as predictable as the performance of these high-quality units, set it and forget it would work just fine. Trouble is, the calendar doesn't always cooperate. For example, you could change over to a summer-grade grease on, say, March 15th, but then a sudden change of temperature could bring about an unexpected return to extremely cold weather and make your summer grease a questionable choice. This is why you need to choose your grease and supplier of grease with care. The right selection can do wonders for reducing your costs of maintenance and repairs. And when it comes to dispensing that grease in sub-zero temperatures, the performance of today's higher quality greases is nothing short of astounding. For example, here's a grease that's flowing smoothly at -30 Celsius, a temperature so cold that it's frozen the very same grade of base oil in that grease. That's right, the oil is frozen solid. But the same grade oil, as part of a well-made grease, continues to flow. Just as it will flow in your equipment, to keep your production in motion at temperatures that at one time would have brought everything to a halt. Here's a tool that can help you make sure of getting the very best performance from today's cold weather grease. These nomographs are available from Esso to help you choose a specific grade of grease for achieving a specific flow through a specific diameter of pipe at a specific minimum temperature. Esso offers nomographs for every winter grease it sells. Your Esso representative also has a good variety of other helpful information as well, including the companion lubrication guide to this Cold War video. Meanwhile, let's keep in mind the 3 key points of winter lubrication: to start up quickly, warm up safely, and stand up to the demands of operating temperature. With so much technology going into so many good lubricants, and with so much information available for the asking, there's just no good reason for anyone to pay the ultimate price for failure. In this, the never-ending Cold War, there are casualties, there are conquerors. And with so much riding on the success of your operation, the need for strong, resourceful allies has never been more extreme. Your friends at Esso hope you found this presentation useful. And remember, if you have any questions on this or any other aspect of lubrication, we'll do everything we can to help you find the answers.